All right. So I'm Neil Davis. I tweet at Sigillante, which is my Urbit related account. And my Urbit ID is lagrevnocfep. So if you haven't seen anything with Urbit before, you don't know what the IDs mean yet, but basically it's my identity on that network. And with 1 to 0, what I'm going to be trying to do is covering the high-level meaning of what Urbit accomplishes and the problems in the current software space and the way that the internet is set up that we face. There's a lot of persistent issues that we've learned over time that are afflicting basically everything we do at this point. It's become more and more exacerbated over time. So as Sigillante, I post weird doctored images that don't quite match each other, that have little bits of these are Urbit sigils. So these are
welcome. Yes, welcome.
Howdy. I just got started, so you haven't missed anything concrete yet. These symbols on this particular story, these are what are called sigils, which are pieces of your identity as well. So that the identity has a verbal component and it has a symbolic component that work together to identify you. So we'll get more into that later on. So I want to start my story back in 2007. So 2007, I started running into the problem towards the end of my undergraduate of how do you actually keep track of things that are going on the internet, right? So I've been using the internet since the 90s, and the problem that would happen is you'd build up this whole set of bookmarks in one browser, and then your computer would die, and everything was gone, and you had like no real way to get these things back, right? Like there was no idea of persistence of sessions across browsers the way you do with Chrome. There was this idea that you could store these online with these services like Delicious, and the really promising thing at the time was that you could start to gather up. So Delicious was a bookmarking and tagging service, so you could gather up all of your bookmarks, you could tag everything, and then you could sift back through. And not only that, you could look at other people's tags. So it was kind of a social media bookmarking site, and that's the way it operated. This is when people were starting to get into recommendation engines, and so people were really excited about, like what if you could figure out like all the people who like all the weird niche things that you like from their tags, and then they could recommend things to you as well. There's like Pandora's coming out and this kind of stuff. And that part of the promise never really materialized into anything. And people put, thousands, hundreds of thousands of bookmarks into Delicious over the years. And then suddenly in 2011, Yahoo decides to sunset Delicious. They didn't even tell anyone that they were going to sunset Delicious. They accidentally released a low-resolution slide that happened to have Delicious in the sunset column for the next year. So they didn't even tell their users this is what was going on. And so what happened over the next few years was this odyssey as Delicious is sold from one service to another, and it eventually lands at being owned by one of its former competitors, Pinboard, which is still around and still active for people who want to use what is now a very old school way of interacting with your bookmarks. And this is one of the early major instances when we started to realize that we don't own our data, right? Like the things that we put on the internet that we aren't posting ourselves, we don't really own. And if you go back to 2005 or so, we really thought that we owned these things, right? That when you had something, frequently you were paying for it. There were a lot of free services starting to crop up around that time. Gmail was starting to be the big one in 2005. Because it was still invite only then, and so you had to know someone who they had a certain 5 invites they could send off, so it was this big deal to get into Gmail. But the problem that we face is that we don't own our data. Do you know what Amazon knows about you? Not really, right? I mean, they know an awful lot of weird things, and they also are in a position of priority where they can compare it to other things that are going on, and they can infer things. I mean, this is, in the extreme limit, you have Google flu trends where they're claiming they can predict where epidemics of flu are going to break out because people are searching flu symptoms, which turned into nothing because it turns out that when you tell people this, they start searching for flu symptoms, and you've worked your algorithm there. So we don't own our tags, we don't own our data. I mean, so in cryptocurrency, if you don't own your keys, what do they say?
don't own your Bitcoin.
Yeah, if you don't own your keys, you don't own your Bitcoin. And this is true of, turns out, just about everything on the internet. And we don't know what they know about us. So my first indictment of the current system is that our data are pwned. Like, this is built in from the ground up in the way that the modern internet works. Like, really the post, probably around 2002 internet, like this is just de facto. Like, earlier than that, you can actually get back into weird stuff, but everyone was hosting their own things and there weren't really services back then. It was just a bunch of weirdos who thought that this might turn into something, who were standing up their own servers and running it in their house on some hardware, and it was like this weird, awful Web 1.0 kind of look. It's one thing to make an economic trade for your data, where you are, like, I choose to use Amazon, and I recognize that there's going to be a transfer of data being carried out in that kind of transaction. But it's another thing to end up where we're at now, which is where we're completely ghettoized, and that we have no access, we have no knowledge about anything that these companies are finding out about us. So that's the first part of the problem. The second part of the problem wants to go back and look at the experience of actually running software. So has anyone tried to install, well, okay, so what are our operating platforms here? Windows, raise your hand. Okay, 2 Windows, Mac, Linux.
I use all three.
You use all three, great. So I'm on Linux now. And if you try and install software from GitHub or somewhere, what are the odds you're actually going to get this successfully installed?
I don't even try anymore.
Right, they're reasonably bad, right? Like, you're just not going to be able to solve this whole problem of how do you get your library versions lined up and make sure that you don't have any weird dependency issues or anything. And on the other hand, so you not only do you have like weird software stack problems, I'm going to call these all software stack problems, and you run into them even on the proprietary systems, right? Like, you can set something up on Windows and you double click on it, and it tells you it needs to install the Visual C++ 2015 runtime, and it goes in and tries to download this weird thing, and maybe it ends up working, maybe it doesn't, right? Like go ahead.
I mean, I'm above average technician, and I found myself having a hard time when I started teaching myself Linux, man. It was like, this is not, it's user friendly.
So everything, right? It's not a Windows thing, it's not a Linux thing, it's an everything thing.
It's in everything. I had issues with Windows.
Yep.
And I'm like, I don't understand how the average person gets stuff done.
Right. So, right, and so, I mean, I'll come back to, I guess, to this one because I want to just touch on this. So, basically, we have a system where we're piling features on features on features in our software, and there's nothing that pushes us back towards simplification.
Yeah.
This is an oversimplification because there are limits on memory and hardware and everything that do kind of keep us from going totally insane. But in general, when someone wants to write a new piece of software, they can write something that's going to work on their own machine, but who knows how it's going to interact with the broader ecosystem. And like, I do a lot of work in scientific software, and like what I say is true for the general world is like 10 times truer for scientific software. It's a mess. Like, everyone has their own specification. Someone says, you know, install this linear algebra sub-package. Well, it turns out that there's like 18 different versions of this because every supercomputer manufacturer, every chip manufacturer has their own tweaked version. Maybe you have access to it, maybe you don't, right? It has all sorts of proprietary edge pieces built in. So this is Alice running with the Red Queen. There's a principle called the Red Queen hypothesis, and it describes economic systems, it describes evolutionary systems, it describes any system where you have to run as fast as you can just to stay put, just to stand still. And this happens with software because, so if you think back, say 10 years, does your experience with your computer feel any faster than it did 10 years ago? Right, like it doesn't feel snappier. You know, if you go work with Google Docs or something like that, spreadsheets, it's not going to really feel any snappier. Sometimes it's going to be slow, sometimes it's going to be fast. But what's happening is because of software bloat, we're always straining at the limits of whatever our current capacity is. So in real terms, you could buy faster chips on the market, single chip, single CPUs in 2008 than you can today. Okay. We backed off of the really fast chips because we couldn't solve the heat problem. It was too hard to cool them efficiently, and so they would burn out quicker. And so we decided, okay, we're not going to go down that road. So what we started doing then was multi-coring everything.
Yeah, there's also was bottlenecking at the bus level.
Yep.
Yeah.
And that's actually where we're seeing a lot of the speed ups now.
Because there was a whole lot of marketing on the processor, the capability, the power, right? All the bells and whistles, but you're not even able to fully utilize all that power. It's like having a car that goes 500 miles an hour, but the police only allow you to go 50 miles an hour.
Right.
Or the roads themselves only you can't go faster than 75 miles an hour.
Right. So if we say CPU, if we say bus, if we say RAM, if we say hard drive versus like a solid state kind of thing, SSD. Right. So back then the CPUs were fast, but everything else wasn't nearly as fast. And now the CPUs are maybe here, but we've pushed the bus up to here, the RAM up to here, and the hard drives up to here. So why aren't things feeling any faster?
It made me want to create fiber optic circuitry was the concept I thought of, and I thought of the quad processor at that time. This was like 2003, around here, 2004. But I didn't know much about, I wasn't an engineer or circuit board. It was just some theories I had.
So there's a lot of ways you can try and get past this. And so there's other architectures like the mill architecture, which is trying to work around the fundamental limits. A lot of these come down to manufacturing problems. We fundamentally have a hard time manufacturing chips that are more complex than our chips now, both because of the size of the lasers and everything that we're using to produce them, and because we have the heat problem. Actually removing heat from the chip turns out to be a significant difficulty. But so what's overriding everything though is that our software keeps getting more and more complicated, right? So if you think about Microsoft Office, this is the poster child of software bloat, because there's nothing that keeps it in check, right? They can keep adding features to it, but how many of these features do you ever use? Right, you install all these things on Microsoft Office, and you pull up the installation page, and it has check boxes and I mean I see supporting all the languages, but there's all these weird plugins and interactive systems and ways of setting up bookmarking, and they're kind of in the position where once they introduce one feature once that someone uses, they can never roll that feature back, right? They can never step back away from that. So my second criticism here is that the stack itself is owned in the same way. Even if you could get things working, bring the software back down, you still couldn't solve all these problems because the right incentives don't exist in this ecosystem. So setting that aside for a moment, people point to, open source software, people are going to build your own thing. So if you've ever worked in open source software and you've asked for a feature, the response has been, that's great, why don't you go build it yourself? Which is a gigantic middle finger to someone trying to figure out how to actually keep something running, right? You don't have the time and resources to do this. Well, neither do they, right? This is why it's an open source software package. And so open source software doesn't really have the resources to chase new features unless it's really centered in a particular corporation that has the wherewithal to do that. It doesn't have the in many cases, it just doesn't have the funding. It just plain straight doesn't have the funding. So this became an issue with some of the SSH, the security layers that are running a lot of our servers. There was a vulnerability that was made known a few years ago, and the OpenSSH developers were basically like, well, that's great, but it's there's 3 of us that work half time on this, and it's the software that a substantial portion of our internet is built on. Wow. And they had, now they call it financial deficit disease, right? So they have this problem of how do you actually know that the things that you're working on are well enough supported that you can rely on them being there and functioning in the way that they need to, right? It's this danger that's always looming over all of this. So the entire stack, the proprietary stack, the open source stack, it's all pwned in the same way. It's you can't fix it given the current model because we've had a lot of time to try and fix it. Okay, so who likes to fill these out? Right? I know, right? And you sit there and you're is this part of the traffic light?
Yeah.
I don't know, right? And sometimes you guess wrong, or it's like they ask you for a bus and you're like looking at this little gray thing and you're trying to figure out what this is, right? You have this total problem. Well, why do we do these?
You're a robot.
Right, so like what is, the problem is that we have all these systems running around, these botnets, viruses, etc., that are spamming all of the systems we interact with all the time, right? Like Twitter and Amazon and these companies have entire teams of people dedicated to like removing fake reviews or shutting down click farms and everything, right? Like it's just this total mess, and it's endemic in the entire system.
It seems like it takes more time now to do stuff. It's like too many steps to do things. Even though we may have like faster speed on some level, it just seems like it's too many steps. You get locked out of your own access to email or Drive.
Yeah.
And I know I'm not crazy, but if I were to keep track of how many times I had to reset a password, and I know for a fact that that password was not incorrect. So there's always seems to be some password issues with the servers reconciling or something. But
right,
it eats
like
up a
you
lot
don't,
of time.
and you don't know what's
you gotta
going
use your
on.
cell phone to unlock it in order to even get into your own account.
And that's for everything
Everything.
piece of code that you're using, essentially. Every
Well, and okay, and even related to that, right? You don't know if you give some service your credentials, like your password and everything.
Yeah.
Some of these people are storing it in plain text on a server that's not secure.
Oh, really?
Like this happens every couple of years. Someone gets hacked, and it's like, well, like.
Did you hear about what happened with Microsoft? Somebody was telling me.
What?
He said something like 1 billion data of users that been compromised like 5 years ago, and they're just not releasing it.
Yeah,
because some company that
everyone-
acquired some Yahoo software or something like that. I don't know.
Yeah, like everyone has this problem sooner or later, right? All the companies have
Always
this
seems
problem.
to be data breach every few years.
Yep. And sometimes it's because it's bad data storage practices. Sometimes it's bad. Sometimes it's human engineering, right? Where they call up and they talk through the right thing and they do that, like that kind of identity theft.
Or you mean like social hacking?
The social hacking stuff. Sometimes it's they're using a service that had a 0-day bug that no one knew about, and then it was discovered that these data are actually sitting all out in the clear in this particular case. Right?
There's still vulnerable 0 days.
Like this happens everywhere, right? This happens all the time. So my final criticism here is that identity itself is pwned. So identity, because it's so cheap, the spammers can always win, right? There's always a way to spin up, if they shut down one domain name that you're operating from or one IP address, you can get a new dynamic one through Amazon or wherever else, right? Like no time at all, you're up and running again. You just have to reconfigure a few things in your basic files back on the cloud, and you're running again, right? So we have this continuous problem.
By identity, do you mean like the user identity?
So I mean a lot of things when I say that, right? So there's the single concrete identity of you as you are the person to which a number of different identities face, right? Like you have a number of digital identities, you have several email addresses, you have logins for different services.
Yeah.
All of those you may in some sense consider compromised under the current system, right? Because if you're using good grief, like what happens if LastPass gets hacked?
What's that?
LastPass is a password.
Oh,
manager,
LastPass,
right?
yeah.
Right,
I
so
know
everyone,
LastPass.
you can store everything in LastPass because it's a secure single point, but then you're really in trouble because they can just go through and sweep everything that's going on. But identity is also, the particular sessions that you're running, right? Like if you're spinning up a browser session, you're interacting with a server on a single time basis. That's a piece of identity, right? Like making a particular call. If you're working with a bank session, that is a piece of your identity, even though that session is transient. You still want security at that level. Right now, we can't really trust almost anything in the whole identity system. We have to, right? Like we do. But we also know that this is incredibly risky because there are data breaches, et cetera, all the time. And there are always these huge, massive things where it's like 100 million credit card numbers are now released into the wild. Right?
It's
And
just like
all those sort of-
viruses. I mean, there's
Right.
no antivirus that's going to protect you from all the viruses, right? All you can do is risk management. Right?
Yep, there's always ways through. So we're here to talk about Urbit. So let's talk about Urbit. And I want to talk about how it intersects with these three particular problems here. So I'm going to give you three different definitions of Urbit. And together this is going to start triangulating on like what we talk about when we do this. So Urbit is a clean slate reimagining of the operating system as an overlay OS and a decentralized digital identity system including username, network address, and crypto wallet. So we have two things that are listed there so Tlon is the corporation that is the primary developers for Urbit. So we'll talk about the source of these names a little bit later on too. So there's two things. They're talking about there's the clean slate reimagining, right? There's this operating system, overlay OS, like whatever they mean by this. And there is a decentralized digital identity system. So those are the two things we're talking about when we talk about Urbit, according to the makers of Urbit. There's another edition, another version of trying to explain it. It's ultimately a hosted OS, resides on top of Linux with an immutable file system with the additional purpose that you build applications distributed first in a manner where clients store their own data. There's also other stuff in there, obviously, with Hoon and Knock and all that. Okay.
Sorry, what's Hoon and Knock?
Oh, so we'll get to Hoon and Knock. These are the programming languages that Urbit is built on top of. Kind of like if you're working in Linux, everything's built on C, fundamentally. That's what everything boils back down to. If you're working on Urbit, everything boils back down to Knock, ultimately, but Hoon is generally the human level way of running that code. And then we've got Urbit is perhaps how you do computing in a post-singularity world, where computational speed and bandwidth are infinite, and what's valuable is security, trust, creativity, and collaboration. It's a combination of programming language, OS, virtual machine, social network, and digital identity platform. So what Urbit is trying to do is it's trying to create an experience where your experience of computing as a user becomes unified across all the different platforms and services you use because you unify it all into one platform that runs on top of whatever else is out there. Right now, that's not completely true, right? Right now, it has to run on a Unix-like system. So you can run it on a Mac, you can run it on Linux. I'm sure there are people running it on the Windows subsystem for Linux on Windows 10, but I don't know what that looks like in particular. You can't run it on raw Windows yet. So it's kind of this hosted operating system. If you've worked with VirtualBox or virtual machines before, then this is like starting up an instance of Linux inside of Windows. It's kind of like that, but we'll see what the experience
Let
is.
me ask you a question. So like, I was around when I was learning about computer installation, and back then, like 2003, like if you wanted to install an operating system on 100 computers, right? You're an IT administrator, server administrator. All of the firmwares, all of the circuit board, everything had to be identical, right?
Right.
And so I thought to myself, well, this is kind of archaic. And so I asked my teacher at the time, is there a way that we can actually serve an operating system on demand and applications? Because I want to be able to get on any computer, and I told him whether it's an Apple or Windows or Linux, and be able to order the operating system.
Mm-hmm.
You know,
Right.
like, you know what I'm saying? So I'm not actually on, it's like a cloud-based, essentially a cloud-based operating system application. So that's what I was looking at creating. Is this something like that?
You could think of it that way in
And I thought
some
about
respects.
it like an overlay over different operating
So
systems.
sort of, so let me draw a line here. So sort of classically, can you see if I draw here? Okay. So sort of classically, so we're going to say we have a chip down here. So
Basically, where the
this is our
computers are
actual
like
hardware.
nodes. Yeah.
Right. So here, this is our actual hardware that we're running on. On top of that hardware, we have, we have a lot of different libraries and services and all sorts of things going on in this particular system, right? If you're running Windows, if you're running Linux, like whatever it is, you have something that lives here that describes what is classically known as your operating system. Operating systems do certain things, like they manage memory. So they make sure that you have enough memory available. So if you go back and use a very old system like DOS, these are the things that are kind of in your face about your experience of it. Like if you run out of memory, or if you don't have enough of extended memory or expanded memory, like whatever things it needs, you're going to have problems actually running the software that you want to run. And it's very, like the simpler your operating system is, the more apparent these elements of it are to you. What the Urbit experience is like is it sort of assumes that you have something that serves this purpose of talking to your machine. And it concerns itself with, I'll draw the Urbit symbol up here, it concerns itself with secure networking and decentralized identity above that layer. So in principle, this would be something that, kind of like a virtual machine that you could run on any hardware, you know, once someone's installed it. Kind of like Java, in theory, would be. So any machine has a Java virtual machine. You can run a Java program on it, which, depending on the complexity of your Java machine, may or may not be true. But what this handles is talking to other Urbits. It handles talking with services, handling all these pieces as you work through this. So in a sense, it's kind of like what you're referring to with being able to call up these particular pieces in an on-demand fashion. Like if you need a particular service, it's basically a network call out to someone providing that service endpoint. But in a sense, a browser does what you're describing as well, right? I mean, like it wasn't something you thought about in that sense.
Yes.
But I think one of the interesting ideas that I've seen explored in the Urbit space is that we actually have, I don't think I'm going to draw this, we actually have, on every machine, we have two operating systems. We have the platform, like the Windows, Linux, Mac, that you normally think of as your operating system, and then you have the browser. And the browser really is its own operating system, right? Like it's doing all these things that an operating system does conventionally, and everything that you do in the browser can be done completely without regard for what's going on in the underlying operating system.
You're talking about the GUI interface?
Well, I'm talking about if I'm running, I mean, even if I'm doing it on a phone, like as long as my app is designed to work on the hardware that I'm running on, whatever I'm doing inside of the app just needs to talk to other instances of the app. Right? I don't need to talk to like whatever's going on in Android or iOS.
It's independent.
Right. It's this completely independent layer. Like everything that happens in the browser, JavaScript doesn't rely on callouts to your file system, for instance. It doesn't require on the ability to have hooks into the way that you're managing your memory. It runs in this completely isolated layer. Urbit is kind of like that. It's still not the same thing as the browser, but it's this isolated layer that if you can provide everything up to this point on any system, it will run above that system.
And independently from that system.
And independently from that system, yes. Now,
I see how that would make it very secure.
So that's the idea, is that we're building it out. So we're taking a lot of the things that we've learned. So what happens with building Urbit is it takes a lot of the ideas that we've learned over the past, say, 20 years about security and builds them into the operating system experience as a first-class thing, right? Networking, like, you know, if you're running like Windows 95 and you want to do networking, you got to go figure out like how to hook up to your modem or like whatever, right? Like it's kind of this afterthought. That's becoming less and less true. Like if you're running Windows 10, networking is kind of right there available from the beginning. But this is assuming that things like your crypto are first-class pieces of your operating system, right? Like you could